Hello everyone. Welcome. Welcome to Vaayusastra Aerospace's Future Scientist Meet. I'm so happy because we reached half century, 50, 50th. This is the 50th chapter. So almost we were doing this for past 4-5 months. Sometimes we usually go for weekly twice. Sometimes we go weekly once. Reached chapter 50 now. Thank you so much for your all your love and support. So for those who are watching it for the first time, let me introduce what Vaayusastra is all about, who we are, what we do. So Vaayusastra is an IIT Madras incubated educational startup in spreading awareness of aeronautics and aerospace among school children and college students. How? We use unique method for school students where we use theater arts, storytelling methods, teach the basics of aeronautics for school children, and hands-on, advanced level hands-on workshops for college students. And we recently uh, we started producing more results. One student called Bhairavi, she published a book on Moon's crater. It's available in Amazon now. And recently, she was awarded a Young Achiever Award along with two more students. One of them is here, Vignesh Anirudh. So for his uh, team building activities and the research works he done. Yeah, and more such talents are coming out. This did not happen overnight. It took 3 years. All the students you see here, Jason, Vignesh, Kashika, Harjit, Bhairavi, all the Sanjay, all the students were with us for more than 3 years, and they know something equivalent to what aeronautical engineer knows. And we will produce more such beautiful results in the near future. Thank you so much. So without delay, let's go for today's presentation. Our first presenter uh, is Jason. Jason Barboza. Okay. So he is always comes up with unique topics, something innovative or something. He comes up with his own ideas and he gives it as a presentation. Where most students go for study research works, like research study. Something already exists, they do study on that. Jason is slightly like creative and he comes up with his own ideas. Last time he presented his own idea of about uh, uh, aircraft. And today Jason is going to present on this topic, gliders in the soaring heights. And he's a grade 4 student from SISHYA. Jason, the stage is all yours. That's a beautiful
Hey everyone, today I am Jason and today I am going to talk about gliders in the soaring heights. Hang gliders. Hang gliders are piloted aircraft having cloth wings and minimal structure. Some hang gliders look like piloted kites, while others resemble maneuverable parachutes. Sailplanes are piloted gliders that have standard parts, construction and flight control systems, but no engine. The space shuttle returns to Earth as a glider. The rocket engines are used only during liftoff. Even the Wright brothers gained piloting experience through glider flights from 1900 to 1903. Gliders are small and light as possible. Since there is no large engine taking up space, gliders are basically sized around the cargo. They usually carry 1 or 2 people. The cockpit of a single-seat glider is small. but it is large enough for most people to squeeze into. Instead of sitting upright, pilots recline with their legs stretched out in front of them. The frontal exposure of the pilot is reduced and the cross-sectional area of the cockpit can be sustainably smaller. In flight, a glider has three forces. Lift acting on it as compared to the four forces that act on a powered aircraft. Both types of aircraft are subjected on the forces of lift, drag, and weight. The powered aircraft has an engine that generates thrust while the glider has no thrust. The first successful heavier than aircraft were unpowered gliders. In 1853, British engineer George Cayley built the world's first real glider. It carried his terrified servant on a short flight across a small valley before crash landing. Later in the 1890s, Otto Lenital of Germany built a series of small fragile gliders. If you look at a glider beside a conventional powered plane, you will notice a significant difference in the wings. While the wings of both are similar in shape and function, those on gliders are longer and narrower than those on conventional aircraft. The slenderness of a wing is expressed as on the aspect ratio, which is calculated by dividing the square of the span of the wing by the area of wing. Control surfaces. Gliders use the same control surfaces, movable section of the wing and tail that are found on conventional planes. To control the direction of flight, the ailerons and elevator are controlled using a single control stick between the pilot's legs. The rudder, as in conventional aircraft, is controlled using foot pedals. Ailerons. Ailerons are the movable sections to cut into the trailing edges of the wing. These are used as primary directional control, and they accomplish this by controlling the roll of the plane, tilting the wingtips up and down. Ailerons operate in opposite directions on each side of the plane. If the pilot wants to roll the plane to the right, he moves the control stick to the right. This causes the left aileron to deflect down, creating more lift on this side, and the right aileron to deflect up, creating less lift on this side. The difference in lift is between the two sides causes the plane to rotate about its long axis. Elevator, horizontal stabilizer. The elevator is a movable horizontal wing-like structure on the tail. It is used to control the pitch of the aeroplane, allowing the pilot to point the nose of the plane up or down as required. Rudder, vertical stabilizer. The rudder is a vertical wing-like structure on the tail. It is used to control the yaw of the aircraft by allowing the pilot to point the nose of the plane left or right. Landing gear. Another way to reduce the size of an airplane is to reduce the size of the landing gear. The landing gear on a glider typically consists of a single wheel mounted just below the cockpit. Sailplane is a type of glider aircraft used in the leisure activity and sport of gliding, also called soaring. This unpowered aircraft can use naturally occurring currents of rising air in the atmosphere to gain altitude. Sailplanes are aerodynamically streamlined, and so can fly a significant distance forward for a small decrease in altitude. Thank you.
Nice, nice. That's beautifully explained
Yeah,
session.
that's the quizzes.
Jason, do you know when I learned this? Only in my aeronautical engineering second year. And what grade Jason is studying?
Fourth.
Grade 4. Yes. So that's the magic. Nice, Jason. That's a beautiful presentation. And it's quiz time. Yes, you can paste the link in the chat box. Yes. So that the audience can join. You can copy paste the
The link, sir.
Yes, yes. Jason will post it.
I did not get.
And Jason knows how to control a paper plane using all the control surfaces. Not only one variety, he knows more than I think easily 10 to 12 varieties. Okay, the link is up.
Yes, I've sent the quizzes link.
Yes, yes, yes. I'm posting it in YouTube as well. Children, join the quiz. So usually in Vaayusastra Future Scientist meet, most students usually hate exams, but the audience here, they want quizzes. They keep asking quiz, quiz, quiz. Okay, Jason, you can share the screen. And let's see how many. Aishwarya, you can post the link in the group as well. Click the share direct link, Jason. Click. Now paste it in the chat box. And go to Zoom and is it the same link? Okay, I think this is the link. Children, this is the link.
Sir, it is coming admin link, sir.
No, now use this link, the 605 find
New link, sir.
new link. Now joined. That's joined.
Good time based it's time based only, no Jagu.
Yes, Jason. Yeah, Jason, is it that time based? Yeah, I guess so. Okay, Sanjay joined, Rexy joined. So we need one more person to start the quiz, I guess. Okay, started. Hello. Ailerons operate in. You should know the answers. Well, this is Trigger the Spark level 1's fifth session. Dead or a sick or a story, you all get to build this hands-on. Next. Is your teacher a monster? Huh? Enjoyed the quiz and presentation? Yes or no?
Sir, but the difficult part is that drawings are very bad in drawing. Very
Draw
simple.
your own version of
Me
glider.
too as well. I'm also
Try.
really bad in
No
drawing.
harm in trying. Try for it. Go for it. I never seen this kind of question ever. This is the first time. Draw your own version of something. Forces on gliders are. This may be regular batch students may know. This is the level 1 session 6-5 types of aerodynamic forces.
So for the last one, I put the same answers. It's not coming, sir. I put lift, drag, and weight.
There may
It's
be
not coming. Look, sir. I took same, sir.
some word like spell errors or commas, these kind of things. Hang gliders are piloted aircraft with what wings? Dash wings. Power up. Oh, you got power option. What is quiz.com? Nice.
Sir, again, sir, I put recommendation question, sir. It's coming wrong. I put lift, comma, drag, comma, weight.
I don't know. Okay, landing gear typical consists of a double wheel, multiple wheel, no wheel, single wheel. Obviously, last two can't be. The third one definitely can't be. Put a ring on it. Hey, what
Sir, I put same things are coming wrong, sir. For
What
the
is
last.
controlled using a foot pedal? I don't know. Ailerons, rudder, elevator. He will show the dashboard and then let's see.
Sir, but the last, sir, but one question, sir, fill in the blank. I just not put one, sir. Space, sir, is coming wrong answer, sir.
Yeah, that's the problem with all the platforms. They need to be exact with commas and sailplanes have no engine. Don't let quiz. Okay, Sanjay is leading it. Redemption question. Three forces on gliders are. I think you have already answered this, I guess. Okay, it needs space. Oh, Sanjay. Sanjay, Vicky, who is Vicky? Darsh, Harjit, Aishwarya. Like all of them are in the same level. So very,
I
very,
am also not Vicky.
very close. All of you are very nice. Like one or two questions are wrong because of this commas and spaces. I think most of you got all the things right. Well done.
And now I want to show a model of a conventional plane that I made by myself. It has a motor.
Oh, you want to show it? Nice. Show the front, back, and all the things. See, that's a model made by Jason.
Sir, on a spotlight. No, sir, spotlight.
It's very good, sir.
Nice.
Spotlight.
Hey, I need to.
Can you fly this and show one time?
Sir, spotlight.
I'm
Spotlight.
thinking something in a place like a sea or something. Like
Isha, can you one just fly it?
Yeah, show it, Jason.
fly it. Huh? Fly. You're holding.
Yeah, he's sitting in the some.
It won't fly.
Okay.
It's a model.
It will move definitely, I guess. Yeah.
Yeah, it will move like this thing. Move.
Nice. That's a
No,
beautiful.
it wants moving.
9-volt battery.
Moving.
Like ice cream sticks.
And I even put it's made with ice cream stick, and I even made a switch. Yeah.
Very creative.
Okay, can you tell me? Can you let it move, Jason? I want just a trial. That's it. Because because I would also like to make it.
Maybe Jason, you can put a video. After this, maybe.
Like this.
Yeah,
but
you
there's
can
so
put
many
the video.
videos. I'll
Because I think he need to move the camera down to show it.
Yeah,
I don't
yeah.
know if it's
Is
possible.
it
It
a
doesn't move.
laptop or a computer?
Okay.
In
he
which
will
device
post
are
it.
you attending?
It doesn't move.
Mhm.
Okay.
We'll take a video. I'll take a video and show.
Yeah. Because in the
If you
level,
have any questions, you can ask.
yeah, if you have any questions on
I'm thinking that is more weight. It has some parts and more weight so that it cannot fly.
yeah, Jason, if the air is coming in
Hey,
the
it will not fly because of the aerodynamics. The wings is something like curve.
it will move. Just I need to see the propeller, whether it twisted or it pulls the air back. All
It
this.
is a twisted propeller.
Air is pushed in the back or front. Check. Can you switch it on?
It pushed in the back.
Okay, then it should have to move a bit.
Raghu, can you stop the quiz?
But I glued the wheels.
Oh, you got the wheels.
Hey, what is a blue color thing?
Okay, then you need to put on rolling wheels. Nice. Actually, it's a good model. It
Yeah.
actually looks like it's a kind of look.
Blue thing
Can we
is
replace the battery?
in the middle is battery and this is the
Like actual remote controlling
This
yellow
is the motor,
plane.
right? The front of. Yeah.
I think so. He could also make a big one where a
Okay.
human could sit and go. You can actually try it.
Cherry. Okay. Thank you, Jason. That's well done. Let's go and use round of applause for our Jason. 1, 2, 3.
Sir, quiz end பண்ணல.
Yes.
End the quiz.
Yeah, quiz. Oh, quiz. You need to end it. Okay.
And who's the winner?
Oh, you need to show the winners. Okay.
Yeah.
Jason, you want to show the winners?
Who's the winner? Sanjay is the first place. Sanjay is in
Okay.
the first place.
Jay.
But I should be the third place. My guess is.
No.
What? Who is this Vicky?
I don't know.
I also don't know.
Okay. That must be Vignesh Anirudh, no? No.
No, it's not me. I joined in the name Rexy.
Okay, fine. Well done, Sanjay, Jane. That's then Mickey. Thank you so much, Jason. Well done. Super presentation. Now, let me invite our
thank you.
presenter. Thank you, Jason. That's Kashika. So Kashika is a grade 9 student from KV, Ashok Nagar. And what's her topic? Let me see. Quick look. So her topic is a milestone in finding exoplanets. So always we are crazy about, all the students here are crazy about exoplanets. And Kashika have this habit of coming up with all unique topics. So this is one such hot topic. And Kashika, the stage is all yours. Please.
Thank you, sir. Actually, it's grade 10 now. Moved to 10th standard.
Oh, grade 10.
Grade
Okay. So on grade 10 student is presenting now. It's rare to see grade 10 students. Yes.
So I thought I haven't presented in a very long time because exams and all those things over and over.
It's a special day. It's a 50th chapter. Glad to have you. Yes.
So so today's topic is quite interesting because it kind of gives you an overbrief about exoplanets and definitely a milestone. I would say you know what that cosmic milestone is, but before I tell it to people, but I want you all to guess what it is. So let me see if you can see my presentation.
Yes, we can.
Can you see it in full screen?
Yes, not yet. We can see the small screen.
Okay. I think it might come in full screen. Okay. So I have a 17th century laptop, so it's very it's loading. Okay.
Yes, it's good.
So if Apple was more affordable, we could have got Apple.
I think soon it will be.
Yeah, soon it will be. or else we'll have our own version of Apple in India itself. Maybe something like that. Interesting to think about. But about exoplanets. So now before I start off with this presentation, I want like any guesses on what exoplanets are. Like you can raise your hands. You can, I know you know the answer. So
Yes.
raise your hands and you can go ahead and say.
So what are exoplanets? You can answer.
Let's give some knowledge. Let's show some knowledge.
There are a few CEOs here.
See you.
Vignesh Anirudh, J Bhairavi, CTOs are here. CIO Harijit, Darsha is here. Hey, what is exoplanet?
Exoplanet
An
is a planet. It's not
exoplanet
in
is
a.
a
It's not
planet
in
which is beyond our
solar
solar
system.
system.
Beyond the
Jagu.
Earth. Okay.
Beyond solar system.
Solar system.
Example is Kepler 457b.
In different way. Exoplanets are the planets which are out of our solar system.
So
That's all we told.
questions like this, the answers come like in exams. We write for 3 marks questions. We write a definition and example. Ma'am will give you 3 marks and done. But think about, like really critically think about what
Like
exoplanets
Kepler
are.
20b,
I can see if you
Kepler
answer.
20b, and also there are many planets. Kepler
many.
2022b.
And there are types are there in exoplanets.
Yeah, there are many photos in exoplanets. We cannot say
Hey,
it
there's
in
a
one
types.
shot.
There are types. One type is super Earth or something else.
Okay,
They
let me ask
won't
you a
be
quick
like
question.
that.
Okay, quick question. Is Pluto an exoplanet?
No, it's
No.
not an
It is
exoplanet.
an
It's a
exoplanet.
dwarf planet.
It is
It is. Why is it? Why is it an exoplanet?
because it's not in a solar system.
But
Because
is
it
it
is in our solar system.
But is
No,
Pluto
it's
a
not.
planet?
Yes, because it's outside our solar system. It's not an exoplanet because most likely it's a dwarf planet because exoplanet will be a little bit bigger. It's not a dwarf planet. It's not an exoplanet actually.
It
Correct.
is an exoplanet because it does not matter if it's a dwarf planet or a big planet.
Right. So any planets that's outside our solar system is an exoplanet. That's the definition, right?
Yes. Yes.
Okay. That's the approved definition you all gave.
Yes. Yes.
So
That's
now
a
we know that Pluto is not an exoplanet. That's because Pluto is a dwarf planet. Okay, beautiful. You know there are more planets than stars in our solar system. We have so many stars, right? Our sun is a star, correct? And
there are many stars.
Your video is stuck.
Yes, there are many stars like many stars that are. It's available on an app as well.
Ashika, your video is stuck.
She's facing
I
the-
think she must have some internet issue though.
So we all learned, no? How what are the ways to find exoplanets?
Yes, sir. I did a presentation, sir.
Yes, using space telescopes,
Yes, sir.
which
Like,
I'm going to also present it today as well, Jagu.
Yeah. So Kashikaa.S, I think she's facing some internet issues. Let she come back.
She would have some internet issue, Jagu, mostly.
Wait, she'll be back with back in a minute. Maybe till that point you can give your points about exoplanets.
See, Jagu, actually, let's start this conversation. Like she told that Pluto is an exoplanet, but Pluto is not an exoplanet because
Why
She said, ask the question that is the Pluto is exoplanet.
okay, why Pluto is not considered as planet?
because it
is in
it's
our
actually
solar
a
system.
small. It's
What are-
outside a solar system and it's located in a belt called Kepler belt, and it's also small. Which it's located in a belt called Kepler belt, and it's also
There's one
small.
more important.
Short and sweet, I can say the line, my answer.
Yes, that's why only.
Yours
dwarf
also
planet-
correct, but shortly, I can, my answer.
There's one more reason.
What is the reason, sir?
I don't know, Jagu.
You guys know it. We already discussed, I think 1 or 2 times. There is another planet close to Pluto
Eris.
in the solar system.
Eris.
How about its orbit?
Neptune.
Well, what about it?
Its orbit is in a belt known as Kepler belt.
Okay.
it continuously expands, Jagu.
Okay. So what happens? What is
When
the
it
relation between Pluto and Neptune? And that's the one of the main reason why Pluto is dropped out of the planetary thing.
yes.
Find it. Till Kashika comes, we can do this.
Okay, Jagu.
Why
Jagu,
Pluto is tell.
the difference is that the Pluto is smaller than Neptune,
Mhm.
and also the another one reason is which like Pluto is little bit smaller. That is a reason, and the another reason is it's located in Kepler belt, so it's also outside our planet solar system.
Mhm.
About that, I don't know the reasons.
Okay. So guys, you know the target space CEO, then aerospace now CEO, and what's Bhairavi's company's name?
Astro Infinity.
Astro Infinity CEO. All these people got Young Achiever Awards recently at IIT Research Park. Next set will be all these CIOs will be
So, sir, I want to know. I doubt is, sir, why they giving that award, sir?
because at this stage, whatever you guys have done is not normal. It's something super, something extraordinary. That's why they gave this award. And next it will be I'll be recommending all other students as well. So maybe yeah, in further a lot of such events are coming up. So we will send your names as well, like Harjit, Darsh, Naman. All these people's names also will be recommended. Don't worry about it. So I think she's having some internet issues. Vignesh, you want to go ahead?
I'm just preparing quiz, so
Oh,
I need
Kashika is
5
back, I
minutes.
guess. Kashika is back. I can see Kashika here. Kashika, you are there.
Sir,
Hello?
I'm actually here, but I'm on my phone. So it's
Uh,
okay without camera, I can present.
no problem. No. If you have presentation, then fine. Or if you can fix it, maybe I can ask Vignesh to go with this presentation. After Vignesh, you can present.
Yeah,
Whichever works for you. Vignesh, you want to go ahead?
Jagu, can you just give me 5 minutes because I need to only prepare the quiz.
Quiz, it's okay.
Yes.
After Kashika's presentation, you can put the quiz.
No, Jagu, I used to put it after that because I want this to end worldwide because I could improvise on this timing factor. So,
Okay.
so if you can wait for 5 minutes, no, Jagu, you can easily.
Let's discuss then. Or Kashika, you want to go ahead? I'm fine with it.
anything is fine with me. If you want me to go ahead, I can.
Okay. What about your presentation? You can share it?
Yeah, I can share it.
Sir, can I show me that?
You want to share it?
Yes, sir.
Kasha, if you want to take Harjit's help, you can share your PPT.
No, sir. Yes, can you?
Oh,
Can you
Harjit
share
has
your
something.
PPT in WhatsApp?
Okay, tell me. Okay. So Kashia, if you want to take Harjit's help in sharing presentation, you can do that as well.
Can you please share your PPT in group?
Okay, I think, okay, fine. Let me try presenting it through my phone itself. If it works out, let me just go ahead.
Okay. Suppose it not work out, so please
Yeah,
share in
sure.
WhatsApp, I will share.
Great. Thank you. Okay, let's go. Yeah, I hope you can see my screen.
Yes, we can.
Is it visible? Is it okay?
Yes, it is.
That is okay and it is visible.
Right. So it's okay and it's visible and right. Wait, let me present it. Okay. So we were about in this slide, correct? Right. So we were talking about a milestone in the discovery of exoplanets and stuff. We were giving definitions of what exoplanets are, and we're discussing if Pluto is an exoplanet, blah blah blah. But and you gave me a pretty good definition of why Pluto is not an exoplanet and what exoplanets really are. So let me I think you already pretty much guessed it. So I wanted you to guess what exoplanet really is, and you all gave me a pretty good definition. But most of the part, no, you don't have to give me a 2 mark, 3 mark question type of answer. But rather than that, you have to critically think about what exoplanet really is. Planets that's outside our solar systems are exoplanet, but then take up examples. Take up examples and think if that is an exoplanet or not. If you consider rogue planets are nothing but they don't have a star that they revolve around, but then they are just planets. They are just planets that are freely up in space. They have no restrictions, no gravity pulling towards them, no star gravity, nothing, but they are just encircling the galaxy. So they are rogue planets. But then tell me, are they exoplanets? No, any answers are open.
Any answer? Who wants to answer it?
Any answers?
Right.
Will you repeat the question?
Okay, so I'll repeat the question. Have you guys ever heard of rogue planets?
Rogue planets.
Rogue.
No.
Rogue? Okay. It's actually pretty, I don't know, new thing. It's kind of a rather definition. Let me write down. Rogue. This is like rogue planets. So these kind of planets are just freely roaming around. So usually when you see or think of a planet, you usually think of a star in between and it's revolving around it. But then these sort of planets, they are just freely up in space. They have nothing. They have nothing that hold on to them, That's the basic definition of rogue planets. Now tell me, is a rogue planet an exoplanet? Critically think about it. Is rogue planet an exoplanet? Don't go up on Google and type is rogue planets an exoplanet.
They're both, I'm thinking.
You think the emoji will
Yes, I think it's an exoplanet.
You think it's an exoplanet. Okay. We got one yes. And any other one? Any other people?
No, 2 yes.
You also think yes. Okay. That's actually a good answer. It is actually, as per our definition of an exoplanet, any planet that's outside our solar system exoplanet. But actually, think about the definition of what makes a planet a planet. There is a set of definitions that
I have a doubt.
Yeah.
So you tell that these planets are freely roaming in the universe, right?
Yeah, they are freely roaming in the universe.
But if they enter our solar system, are they still exoplanets?
I think so. If you consider them as a planet, they still are. But so we say Pluto as a dwarf planet, right? And we also say this as rogue planet. So there's a definition of planet, rogue planet, dwarf planet. Within the planet, the section of planet, we separate them into rogue, dwarf, and all those stuff. Now, my question is, even the subsection of planets, are they considered as exoplanets? That's the point I'm trying to get at.
I think yes. Until they enter solar system, it's an exoplanet, right?
Right. Now, yeah, but my question is, even if they did not enter that solar system and they're outside, like a dwarf planet, or a rogue planet, are they still considered as an exoplanet? That's my question.
Yes.
Right. Actually, that is correct. We can consider them an exoplanet, even though they are subsections of what a planet definition is. Even we can say Pluto is an exoplanet, but we consider Pluto as a dwarf planet, right? We consider Pluto as a dwarf planet, but it's still inside our solar system. So that's the point you have to think about. So that's why we don't consider Pluto as an exoplanet. But rogue planets that are outside our solar system, which doesn't hold on to any stars, but are still planets, it can be considered as an exoplanet. Right. I think the wait is over and we finally got an answer to it. That even though they are rogue planets outside our solar system, do not have any star or gravity hold on to them, but they're still considered as exoplanets. I think you kind of think about it, it makes more sense. Now, the actual milestone that I'm talking about is that over 5,000 people, 5,000 exoplanets are confirmed and are discovered. So there are more than 8,000 that are waiting to be confirmed. But there are actually over 5,000 exoplanets that NASA has officially confirmed last week. Maybe it doesn't seem like a huge amount, like 1 million or 10 million or something, but 5,000, over 5,000 actually, it's a huge deal. It's because, see, every single planet that we found out until now, like over this 5,000 amount, every planet that we found until now is very different. Like each one have a very distinct feature with them. And in this search, what exactly are we trying to find? So I want you to answer this question. Tell me that by finding this exoplanet, what is the ultimate goal in search? What are we trying to find among them? Any answers?
Tell me.
Guys, question is, what are we trying to find?
Yeah, what are we trying to find in exoplanets? Hey, all of you are doing research on the exoplanets.
Yeah, I thought that will be a pretty interesting topic because everyone is very well versed in it.
Repeat your question.
Okay, I'll repeat my question. We are finding this many exoplanets, right? And officially over 5,000 exoplanets were confirmed. But within these, by trying and finding some planets outside our solar system, but what is our ultimate goal in finding them? Why are we finding them? That's my question.
So you're searching them because there might be alien, might be real, or
Okay, that's a good answer. That's option 1. We can keep that as option 1. Now, there's actually one more pretty good reason for it.
Because to get to know about our own planet, as the planet might be like Earth only, and it might be having some.
or we can colonize and settle there.
It
Okay.
might be like Earth,
Amazing.
and we might get to know about our planet.
Okay. Amazing. That's all the answers that I expected. 1, we might find some alien life, and 2, that we might, kind of learn more about ourselves and our planet. And 3, find a home for ourselves, find a second Earth. That's basically the definition. Because we all know that.
There are so many. I got on news that like same thing like Earth, but there are like so many exoplanets like Earth. They're having the features like water, hydrogen, oxygen, and lands like Earth.
Mhm.
And there are something they are big of our bigger than our Earth, and smaller. Some are smaller than Earth. That is, you're saying that a type of exoplanets named as they are super Earth. They are saying.
Exactly, super Earth. We will be discussing about them in the presentation further down. I don't want to bore you with all the facts and information at the start itself. But then, this is the milestone. This is the cosmic milestone. Over 5,000 exoplanets have been confirmed. That's a huge deal. That's because this is 5,000 in the 21st. Are we in the 21st or 22nd century? That's also another of my question. Which century are we in?
Hey,
Are we in the 21st or 20?
we are in 21st century or 22nd century.
Oh, we are in
22nd.
22nd century, yeah?
Yeah.
Yes.
What?
Which century are we in?
21st century.
21st century, okay. Okay. We are in 21st century. But okay. Oh, okay, fine, got it. So we are in the 21st century. Then in this 21st century, we found over 5,000 exoplanets.
We are not in 21st century, Kashika. We are in 20th century. 20th?
There.
Yes, sir. 20th century only.
Sir. Nah. I am confused. You're making me more confused.
Sir, Jago, we are in 20th century or 21st century. Jago, you say Jago.
1900 to 2000. 100 years. Maybe we can call it as 20th. 2100. 2000 to 2100.
Sir, Google account check பண்ணி சொல்லுங்க sir, please.
ஏய், அதுதான் எக்ஸ்பிளைன் பண்றேன் தெளிவா.
Yeah, Jagu sir is correct. I said
2100.
Sir, இப்ப எந்த century answer முதல்ல சொல்லுங்க சார்.
You find it. These answers, I can't tell. These are all
Sir,
very.
in 21st century, sir, and the year in which year we are in, that starting to this is we see we should multiply or something.
Just go into
Calculations there.
If you can later find it.
Forget that calculation, but I'll check in Google.
You say,
Check in Google and let me know when you find the answer. But exactly the point I was trying to
Putin
make.
is 21st century. What logic and common sense what they have put on?
Yeah, 21st century only. I'll share screen.
You share screen at the end. This is another different topic. We'll come to it later.
Okay, last.
Okay. But actually, the point I was trying to make was that in 21st century itself, we found this much exoplanets. Then imagine what will be with advanced technology in the next century or so. It will be more than that, really more than that. And in that case, we have some hope of finding an alien life or finding a new home for us, all those new stuff. It's exciting because, we cannot use or be on the earth forever, right? We have to find another home. But actually one of the predictions that Stephen Hawking made, along with other predictions like robot uprising will come and alien artificial intelligence life will come up. He also predicted that we aren't meant to be on earth forever. We have to leave the earth. So that's an accurate prediction actually. So I want you all to read this quote first. So the thing is, two possibilities exist. Either we are alone in the universe or we are not. Both equally are terrifying. So can you fathom the fact of this this thought itself? Two possibilities are there, correct? We are either alone in this entire universe, which means we are the only living creatures. Just imagine, have a vivid thought. There's no one like you, no other life form like you, no life other than that you can see. But also there's another possibility that there are millions of life forms, millions of human beings, millions of earth-like creatures are out there in the solar system or out there in the galaxy or out there in the universe itself. But if you think about that, both are actually terrifying. Either you're alone, which is also terrifying. In the second case, there are so many people, so many life form like you, which is also terrifying because, some might be very smart than us, some might be more civilized than us, which could start a war or something. But this is our advanced scientific fictional thought as of now. So, and I hope you all read this quote or thought, and I want you all to speak about what you think about it when you read it. Anything?
Yeah, I understood it.
Right, you understood it. What do you think about it then? What do you think about this quote?
Like the quote means that either we are like alone in the universe and we have no one, like no living organism, or we are not. We have any terrifying aliens, terrifying creatures in the world. Both are equally terrifying. Both are frightening.
Both are very much equally terrifying. Correct. And I hope you got this idea of this quote because it's a possibility, right? It's still a possibility. Anyways, now I guess we already discussed this topic, or what's an exoplanet, and I got a lot of good, amazing answers from you all because you all are exoplanet researchers, so experts in that. Anyways, moving on to that, I told you, I know you all know the answer, and I was correct. You all knew the answer. Anyways, let's move on then. And it's just a definition of what exoplanet is. An exoplanet is any planet that's beyond our solar system. But the one question I had in mind was that when they mention any planet, does that include dwarf planet, rogue planet, other subtypes of planets? So that's the question I gave to you all. You can take it as a quiz home assignment or something and think about it, really research about it. So the question is, when in the definition, when they say an exoplanet is any planet beyond our solar system, does that any planet mean a rogue planet, a dwarf planet, all those subtypes of planets? So that's a question you can take home or you're actually home only. You can think about it after the presentation is done, after the session is done. Great. So the thing is, a lot of exoplanets that we found until now, with technologies that we are capable of, is within the Milky Way galaxy. So okay, okay, this is a basic question. Which galaxy do we live in?
Milky Way.
Milky Way galaxy.
Milky Way galaxy.
It's a
Milky Way
first-handed
galaxy.
question.
First-handed question, correct. That is a first-handed question for you all guys, because you're in Vaayusastra and we learn about all this earlier itself. But maybe if you go and ask a first-handed kid who's studying in school, he might not be able to answer. Yeah, correct. But this is all first-handed question for us. But yes, that is correct. We all live in the Milky Way galaxy. That is our galaxy. We live there. But the fact is that when we live in this galaxy, correct? So when we launch telescopes and all those satellites, and when we observe it, our technology is only capable of to actually confirm it. It's within our galaxy, because that's we cannot reach Andromeda galaxy and see what exoplanet are there. We can, but that's not a clearer image, right? Because it's so far away, and we have to improve our technology. That's for sure. We are still doing that. But the Kepler Space Telescope actually proved that there are more exoplanets in Andromeda galaxy or other galaxies in our solar system. Definitely. And another fact is that I think you all have seen this particular site, this image. And actually, I was going to show up a lot of websites to people in the further upcoming slides in my laptop. I opened all the sites and I wanted to show you all some exoplanet surfaces. I hope I wish I could show it to you now on the phone itself, but I'm waiting if the laptop could open up soon. I could, at the end of my quiz, I could show you all the websites there. Anyways, exoplanets are definitely made up of different elements that is in our solar system, different planets. And also, I actually want to tell one more thing, that there's something called the Messier Marathon, which is Messier is a astronomer, and that astronomer found over I don't know 60-80 objects in our solar system, and he named it and categorized it.
68 objects.
Huh?
Is it 68 objects?
Which one?
The astronomer who found the objects in our solar.
Oh yeah. Oh, you're telling that 68 objects.
I want to clarify again. What's the number? Can you say again?
Let's check now how many objects he found. 1 second.
I had internet issues that time, so that I'm asking.
Oh, you're asking. Okay. I'm actually not sure. I think he did found more than 60 or 70. Let me just clarify that for a second. Okay. He found 80. He found 80 objects in the night sky, and he categorized it. Okay, remember this was in the 1800th century. So this month of April and March, at the end week of March and starting of April, is actually known as the Messier Marathon. People all around the world would go up and do astronomy camps. Just an extra information for all the astronomy enthusiasts. So getting back to the topic, and this is actually almost exoplanets are definitely made up of similar elements. There are the similar elements that planets in our solar system is also made up of. But actually, the combination of them is different. That's what makes everything different. If you think about it, atoms, there are several atoms, right? Hydrogen atom, carbon atom, oxygen atom, but the combination of them makes different substance. So that's something you can think about as well. So now the question is, there are so many planets. There are so many planets like us. There is Earth-like planets. The first image you can see, there are Earth-like planets with land, water, and all those things. And there is also hot Venus-like planets, which is so hot that surface itself is made up of lava and magma and stuff. But there is a difference between lava and magma. Magma is something that when the lava is inside the volcano. So where Venus-like planets means when the surface is filled with lava. So that is so hot like Venus.
and Earth-like planets. There is different types of exoplanets itself until something that we know. Now tell me, what is something that you see very different in this GIF or GIF? What is it you see different? No guesses? It's very simple.
Can you repeat?
So in this GIF or GIF, what is something you feel is abnormal, which is not usual?
Alright, boys.
Very
Are
easy.
asking a question from this picture.
The image
Yeah.
something looks abnormal.
What looks abnormal? The answer is right in front of your screen, people.
Yes, something Jupiter's big and
For me, first from far it looks like round. When I go close, it looks like on muttai.
Yeah.
yeah.
So that is actually like what is that called? A shape?
Egg.
Oh,
Oval.
block.
Yes, it's like egg.
Oval.
No, sir. That
Oval.
one.
I don't know what is this planet. It's like Jupiter.
I mean,
It's
that
like
is
But the
little bit
eccentricity is
bigger.
very high. But
Is
the
that is
eccentricity is
exoplanet?
very high. So, but
Okay,
its eccentricity is
you
very
know
high.
why?
This-
You know why it looks like this? You know why it looks like that oval shape?
I don't know.
Because
The thing is-
because it's very close to its star.
Exactly. Smart. Who answered it?
That's
Dash. Exactly. Dash. Exactly what Dash said is there's a star right here, and this, let's say this is the planet here, and it's so close to the star, and it orbits. Due to the star's gravitational force, one part of it goes like this. And that's why it gets its motor shape or egg shape. It is definitely a good answer. Thank you, Dash, for seeing it. And
Because
that's just
because I just amount of eccentricity.
Hey, can you go before the slide?
go there.
Okay, after.
That's right.
This is the types of exoplanets. Right?
Yeah, this is the type of egg. I just wanted to scroll through it before I actually wanted to show the website. But let's see if okay. Now I want to throw some questions at you people. Now, among all these types, which type do you think is something we can live on?
Super Earth.
Super.
Super
Okay.
Earth.
Super. Why do you think we can live on that?
Because it same thing like our
same
Earth.
thing like Earth.
Shape. Okay, beautiful. Why don't you think we cannot live on terrestrial planet? Terrestrial
And my
type?
guess is that we can live.
We launch from our rocket and just go there and
No, Harshit, you need to find it with the meaning. Okay, terrestrial means that
I know
land. Okay, so there people can live.
in future that anyone can do.
In future, using what?
There's
will we do?
anything we can.
Okay. So there's one more category called gas giants. Any
Gas giant we
example?
cannot live.
gas we cannot
because
live in that.
because it has hydrogen and helium gases.
But half of our solar system is made
How
up
we
of
can live in
hydrogen.
that gas?
No, Kashika, it's made up of nitrogen. Our Earth. In hydrogen and helium, we couldn't even survive. So the problem in gas giant is that, and secondary, do anyone know the news that when Jupiter's surface is a liquid type? Okay, so when you step on the surface itself, we will go into the soil. So like that, it could be.
Liquid.
Okay. Why can't we live in something called Neptune like?
We can't live due to the air and its surface is the temperature is so cool there. Neptune like, and also it's a
like
water. So in the soil we cannot even survive.
Yeah, we cannot survive.
Okay.
And I'm thinking terrestrial and super Earth we can live because this terrestrial is something look like Earth here. See.
Okay.
The atmosphere.
So terrestrial, I think so, Kashika, it could be possibly lived because terrestrial will mean that it will be full of grasslands. There won't be water. So where do you get water? That's the question which I have. So my
Okay.
wish is that we could survive, but we must take water bags from Earth. That's the
Okay, do you
issue
think
there.
Mars is
I'm
an
thinking
example of
in the
rehearsal?
atmosphere there's hydrogen.
In
and
Mars we
oxygen is
get
there.
water.
We can mix
In
them
Mars
and
we
we can make,
cannot
right?
get water. There are some rivers in Mars. The Nagar crater had found. We need to analyze the river water. If it is pure, humans could drink. In
I'm
Mars
having
there is
another idea
rivers.
that they hang atmosphere, right? Suppose they had hydrogen and oxygen, so with that we can make water, right?
Okay,
Yes,
correct.
but
Then you need
there is a
chemical reactions
problem.
for
But
it.
there is a problem. But in Mars we get natural water as well. But there are still the problem there. We
But
using
actually,
hydrogen,
no,
oxygen, we
actually,
can
no.
make glass.
Let me just give one point before you move on. In Mars, we don't get natural water. It's actually frozen water. We cannot say it as water. We cannot describe it as water itself. We should explain it as frozen water because it's frozen, right?
Yeah,
But we can melt it as well.
yeah, we can melt it also
actually
as well. So like Elon Musk said, I put on nuclear missiles on pole of Mars, and they ice will melt and
nuclear
get
would
water.
mean that
Elon Musk
Mars
said
will
that.
be destroyed. We shouldn't put
I think it's
nuclear.
a dry ice, da.
Yes, we need to only put heat containers near it, and we need to heat it during summer season on Mars.
So
Using summer
that's
season.
frozen carbon dioxide. We cannot breathe it easily. So
Correct.
let's go ahead.
Yes, but frozen carbon dioxide, we also drink like Coca-Cola, Sprite. These are also are put carbon dioxide with pressure.
Is Coke frozen CO2?
No, it's not
It is
frozen
filled with
CO2.
air CO2. It's filled with air. It's not.
Yeah. When we heat it, it will become into Sprite and Coke. We need to just analyze it, Kashika. I think so. We need to analyze it deeply.
We can have
Okay,
this debate.
as Sir said, water is on Mars, but they are in form of glaciers. But usually there is CO2, frozen CO2. There is dry ice. I think most of us are familiar with dry ice. What is a dry ice, right?
Yes.
Actually, at this point, I actually was going to show some of the surfaces of exoplanets, how they will look. But my best guess that I would do is that I would finish the rest of the presentation, and then I would let someone else present, and then maybe I could present my quiz and this explore some websites at the end. Is it okay, sir?
Yeah, yes.
Okay, great. I won't take
I'll
much
share the
time.
Google page.
I'll share, actually, if I could find the link, I didn't paste the link yet. That's the
Can you
question.
stop share?
Okay, Jagu, can I start presenting? The quiz is ready.
I have a few more
Great,
slides.
great.
I'll finish this.
Hey, there's some. She wants to do some.
What?
Right. There's one more question I have for you all now. One more discussion to go ahead. Okay. There's actually a discussion, a debate on when was the first exoplanet found.
I don't know that at first.
Okay, I know you won't have the statistics in mind, but I'll give you all 2 minutes. 2 minutes. Go on Google, search everywhere, anywhere. 2 minutes.
But Kashika, I have a doubt. Why we need to share? Because we are only going to colonize the planet. Why we need to know his?
Hey, first, deliver to speak fully.
No, what was the question, there?
Because my question is why we need to see the history of the planets?
I found it.
If you tell this to Karthik sir, Vaayusastra will give you an entire lecture. Why we need to know history? This is a big debate. I also asked him the same question. So, because history is very important. So in school, why do you study history? Because we learn from history.
Karthik.
Psychoscientist.
Yeah.
Psychoscientist.
It was discovered in 1992.
1992. Okay. Any other answers? Any other?
In January 1992, it was discovered by Alexander and Dale.
But can you all notice that I wrote 19 this
19.
slide?
Yeah, why?
Why? That's my question. Why do you think I wrote this? Anyways,
I think they confirmed this at like they found it in 1990 and confirmed that this is in 1992.
correct. Ding 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 ding. You're correct. That is correct. They discovered it in 1990. Confirmed it in 1992. Perfectly correct. That is it. Who said it?
The first exoplanet was being found in the end of 20th century.
The end of 20th century is 1990s only. Okay, who said that answer? Like confirmed, discovered. Who said that?
Harjit.
Harjit.
If for what answer like something you said?
Sanjay, I only told.
Sanjay told. I said the 20th end of 20th century. Okay. Jagu, can I present now?
Wait, I'll let her compute.
I thought he had completed already.
No. Sorry, I didn't complete yet. There's just a couple more slides. We'll go through that and then complete.
Hubble and Kepler and new one for search more exoplanets they launched on James Webb telescope.
Correct.
And James Webb telescope help us to see more, not only exoplanets. It can how the universe formed and so many things it's going to form.
Correct. How the universe formed and all those things. Yes. So definitely that telescope that has helped us throughout the way is Hubble. And I actually wanted to show one more slide on Hubble, but I couldn't show it now. But and then there's Kepler Space Telescope, and there's Spitzer Space Telescope. But at this, we're coming to TESS. I want you all to observe one thing and tell me what's the difference you find between TESS and other telescopes.
I don't know about this. Yeah, sure. That's the first time I'm seeing it.
First time you've seen this? This is actually very important. We discovered actually half of the exoplanets using this. Yeah, you don't know this, guys. We use the
The thing is open. Like the boosters, it has 4.
Okay.
That is engines I'm thinking.
Any other
yes,
guesses?
but it's always out. But this is inside.
Okay. Any other guesses?
I don't have any guesses. Okay. Yeah, I'm thinking how it found half of it. Is there any telescope? Or other like Hubble or
use the transit method.
Yes, I think so. It will transit about exoplanet. In transfer, I'm thinking using this transfer technology, we can find more exoplanets.
Right.
No, it's not transfer technology. It's just a simple path that could help us to cover for a long distance.
Right. Transit
method is just in the shadows. Find the shadows.
Yeah, transit
like
method
this way we can find more
planet. When it goes around this planet, there's a dip in light. Using that dip in light, we discover that there is an
in this day like this method we can find more exoplanets.
Right. But I guess you all didn't exactly before going to this video.
Most human history. I could hear the sound.
You can't hear the sound?
Yes. It's not an issue. Captions are there. We can easily read it.
Actually, I think there is no audio for this thing.
Yeah, and phone we won't hear. It means okay.
Okay, before I jump onto that, the difference in time.
But sometimes the captions don't work properly.
I think so. You need to show it in computer.
But just try.
Because there's no audio for this video. There's just text.
Can you share the link?
No, in this actually, if the video is sharing,
there's
the option will come here.
I already once saw it, but I didn't know that.
Kashika was just try to on and off that sharing screen.
Yeah, there's an option share sound.
Just try that then.
On the arrow marker, in the corner.
Where is the arrow?
In the left corner, you can see one.
Hey, go to more.
No. On the share screen, there is
meeting settings.
I think that those things are fine. On the left corner, you can see one small arrow.
Left corner.
Stop sharing. That time we'll get option for advanced. That time we can do.
Stop.
No, wait, I'll put one annotation.
Okay, let me stop share and share it with audio. That's it.
Picture.
Start now. I think let us see if you can see it.
India and the okay. So
it's just Actually, there's no audio itself for this.
Yeah, there's
There's
no
just
audio.
background
Just
music.
play it. Just
The
play it.
screen stuck.
Just see it, guys, and then let me know.
There is no option.
Actually, sometimes it'll come an option advanced.
Okay, watch videos. But over the last 30 years, we have been discovering planets that orbit other stars and tally just past 5,000. Thousands were found using NASA Kepler Space Telescope. In grid-like view encompassed more than 150,000 stars. Everywhere we have looked, we have found planets, and there are so many stars left. These 5,000 worlds include an incredible variety of planets, places, wonderful. Carrot 9b, example of hot Jupiter, is in tight scorching.
Or giant gas.
The TRAPPIST system contains 7 Earth-sized planets orbiting small red star barely bigger than Jupiter. TRAPPIST. Kepler 16b orbits 2 stars like Saturn and Star
Wars. Huh?
5,000 exoplanets certainly sounds like a bonanza, but it's only a tiny fraction of all the planets in our galaxy, which could number in hundreds of billions. Current and future telescopes will not only fill out or map of exoplanet, but fill in details of their atmosphere. Perhaps someday they will help us find potentially habitable or even inhabited worlds.
NASA. Is the presentation over? Wait, Ra.
Think I might end it here. There's actually no more slides to this. There's just thank you slide after that.
Then it's finished.
Yeah, we are finished, but then I still haven't got a proper answer for this one. Why is TESS different from other telescope?
Why TESS is different? Transiting exoplanet survey satellite.
I think we can research this after everyone presents. I think so.
I'm thinking it is different because it is using the
Which is the most which is the
transting tech.
I think it uses
which
radial
method
velocity.
which method
Because
is
other
I guess because most of the satellites use radial velocity method, but where this satellite uses transit method.
No, with the actual difference, let me tell you.
I can say another one that because other telescopes are using telescope found exoplanets, but this is using another method.
No, the small tiny difference here is what is written here.
telescope?
Right, what telescope is written there? Now, what is written here?
Spitzer Space Telescope.
Telescope. What is written here?
Transiting exoplanet survey satellite.
Satellite. That's the difference. That's a telescope, but it's satellite. Satellite, which is finding an exoplanet. That's the simple difference.
Okay. I said
All
that.
the others are telescopes, and this is not a telescope.
This is
Yeah,
not a
I said that
telescope.
only. This is not a telescope. I said that.
Who is that? Okay, I so sorry I missed that. But that's the actual reason. So after this, I was actually done. So thank you. Actually, I was going to show a few more websites and quiz. But once everyone finishes, if you have time, I'll do that.
Okay, thank you.
I'm thinking there is not
elaborate discussion on exoplanets. It's a wonderful session. We had a lot of interaction today. Thank you so much, Kashika. Let's give a huge round of applause for Kashika for presenting in chapter number 50. Yay! Nice. Thank you so much. So she has something more to present, but maybe at the end of the presentation, like all the 5 participants or researchers.
So, who's the last presenter, Jago?
That's Sruthi Rukmni. Next, we have our Vignesh Anirudh,
CEO of Target.
CEO of Target Space. So those who are following Vaayusastra, you might definitely know Vignesh. So he recently got Young Achiever Award for his works in this. So he's a Chettinad Vidhyashram student, grade 6. And he's going to present on the topic, something related to exoplanets, like following up Kashika. His presentation on the topic space telescopes. Yes, Mr. Vignesh, what a start.
Thank you, Jagu. Thanks for the opportunity. So, hello everybody. Good evening, and my name is Vignesh Anirudh, and today I'm going to present on this topic, space telescope. So, usually in my presentation, before we dive into the topic, we have an introduction. So, like that for this presentation also, we have an introduction. So, my name is Vignesh Anirudh, as you know, and I'm the CEO of Target Space. And also, I want to mention this new point that I got recently a prize on IIT Madras from a company called Thoril Valarchi. The CEO of the company is Abdul Rahim. So, thanks to Thoril Valarchi company for giving me this wonderful award, and Jagu sir as well for recommending me. And also, I'm a grade I'm a grade 6 student on Chettinad Vidhyashram. So I'm also a proud student of Vaayusastra. So how do I came into this Vaayusastra? For the new people the people who are following know how did I came, but the new people. So first, when I was small, I got interest on this aeroplanes, aircrafts, and etc. So I was always, and also is fascinating about Neil Armstrong, Edwin Aldrin, many astronauts and scientists. So after that, after few days and few years, my uncle is the CEO of Specialty Invest. His name is Vignesh Rajaram. He told me that there is a course in IIT Madras known as Vaayusastra. There they make young scientists. They will teach them how to do aeronautics, aerospace, and many things related to my life. So he told that you can go to Vaayusastra. They can. So first, I was put on an online course. I started only during pandemic. So the model is known as Trigger the Spark. They teach many things related to stories like Ramayana, Mahabharata, and etc. So until October 2020, I was doing this module. There are totally 8 sets. I completed them. After that, I was transferred into a place called Young Researchers School, where they make their own presentation, build their own company, and do extraordinary works which could make your dream, change your life. That sort of a thing of Vaayusastra. So I currently form a company known as Target Space, and now currently we have 7 members. And Vaayusastra, I got interest on researching on space technology. Like today, they told that transit technology, extraordinary technologies, and also mass colonization about a universe and evolution early. When I was small as well, I usually see dinosaurs, dragon movies, and extraordinary movies on this dragons and dinosaurs. So I got interest on these both of them. And also I learned how to build a spacecraft like starship, spaceship, etc. After that, I have done 59 presentations and 9 live streams, which is my 60-year presentation and 10th live stream. So I spoke on this topic, deep space network, and 7 presentation total I have done, and 5 presentations on about our about planets, Eris, etc. And also 14 presentation about our space, and 5 presentations about a missile, 1 about cobots and quantum computers, 1 presentation I did, and 1 about solid, liquid, and gases, and 26 presentations on mass colonization, and live streams which I have done in deep space network and space topics. And this is my link for my YouTube channel. I'll chat it in the chat box after the presentation ends. So please subscribe my channel and click the bell button so you can be a part of our notifications.
I already did that for your channel.
I'm asking people who have not done, and I would request everyone to be in mute, because this presentation will be really interactive. I wish it to be about my company. So I have done 11 presentations and 4 live streams in our company. So we have registered currently 3 websites, and we have currently 1 YouTube channel. And so these are the links for our websites, and these are the links for our YouTube channel. So in our company, we have currently 7 members. So including me, so first is me. My name, I am the CEO, Vignesh Anirudh, which is me, and We have Harjit as our MD, and we have J Riya as our CIO, Chief Innovation Officer, and we have Naman as our CTO, and Bhairavi as our Development and Research Engineer. Sai Sirmati as our Product Manager, and Sunaina as our Manager or Research Scientist. Also, we have currently 3 departments: Mars Explorers, where we research on Mars colonization; Exoplanet Explorers, where we research about exoplanets; and Target Space Engineering, where we we'll build instruments for a rocket boosters, etc. on this department, and we'll put an extra materials we will do, and we'll send it to the company where it will help them in the project. There we will use this department, Target Space Engineering. And also, now let's dive into the topic. So the topic name is Space Telescope. So chapter 1 I'll be taking about this topic, about space telescope. So agenda for the day is what is space telescope. So basically, can anyone say what is a telescope? Anyone? What is basically a telescope? Anyone? Dash, Harjit? Anyone?
What is a telescope you're asking?
Yes, what is actually a telescope?
Yeah, telescope is something like from here we can see the far away things.
Okay, Harjit, your concept is correct, but I want this in proper definition. Like you need to, okay, if you don't want to say as well, I will say with the proper definition, but your concept is correct. In the proper definition, you need to say. That's only the matters. Okay, Harjit, you have any clue? Can you tell it to me in proper definition? Do you have any clue?
Something I said right. We can see from here and like something.
Your concept is correct. I'm not saying that your concept is wrong. I need it in proper definition. If you can see, you can see. If you cannot, you can lively tell cannot, and so I can explain.
I need to say the answer is really in the slide itself.
Okay, so you are not, so you don't want to say. Okay, I will tell anyway.
I know, but I don't.
You know the concept. I'm not denying. I'm not saying you don't know, but you need to tell in proper definition, like in a proper definition for a telescope. So as Harjit told, a telescope is nothing but an object that is used to see the objects that are far away from us. So that's only a telescope is. So man has discovered many things with this telescope from Earth. So man, the person thought that in Earth we could see many planets. So why if we launch in our low Earth orbit or any orbit outside our Earth's atmosphere, we can discover many planets. And he told that we can make it as a high efficient telescope. So they bring with this idea space telescope. So it will collect images and it will send it back to observatory where the place where they observe, they will get the information and they will do. So this is how a space telescope will work. It helps us to find many extraordinary astronomical objects which are above, which are away from our Earth. So that this how only a space telescope will usually process and how it works. And it was founded by a scientist known as Liam Spitzer. He's an American scientist. And also now let's see structure of a space telescope. So there are totally 8 parts, which are the aperture dome, secondary mirror, radio antenna, solar panel, support module, primary mirror, and axial scientific instruments. So what is this aperture door? So aperture door is a door that safeguards us from sun damaging lights that could damage the full telescope. So interior where all the instruments are located, so it will prevent the sunlight, it prevents them from damaging the instruments which are inside the space telescope, which helps us to see objects that are far away from our planet. And secondary mirror, the secondary mirror is attached to the probed the secondary mirror is attached to the probed opposite of the main mirror. So what is the secondary mirror? So secondary mirror is a mirror that collects the light that collects the light from the universe, and it will produce us to give the better clarity. So main mirror will help us to produce in a proper clarity. So the light, it will gold coated it and it will send it to the opening of the main mirror center, which is located almost here. So it will help us to give a proper clarity of an image which you take from a space telescope. After that, radio antenna. So a radio antenna is also known as a radio telescope. So basically from the main mirror center, and from from here it will transmit the radio waves out, and it will get the details. After that, it will be put into a radio antenna. So from the radio antenna, there will be a small box. So from that, how do we get the images in Earth? That will be the questions for everyone. Like we now in the digital, using digital technology, we can connect actually. Like we have Bluetooth, extraordinary things, and so from the box we'll directly get to our Earth, and we can see it in our computer. They will be sending it to a specific place, observatory, and from that we'll see in computers many things. We get many information about. So this plays also an important role. This radio antenna, and also solar panels. So solar panels, as everyone knows, it powers the sensors. It will activate them, and it will activate the heating and cooling and electricity of the space telescope, and also support module. So it's a module which supports in any problem in the space telescope. It contains of batteries, gyroscopes, reaction wheel, and extraordinary electronic things are contained in these areas in the space telescope. And primary mirror. So a primary mirror is it will reflect the light. So the secondary mirror will take the light. So it will observe the light, and it will reflect, and it also helps us to give a proper clarity. It will reflect the light outside using the main mirror. And also axial scientific instruments. So these are the main instruments. So these instruments help us to analyze the objects in our universe, which are camera, spectrum, and infrometer. So what is camera? So as everyone knows, camera help us to take pictures. So what is the spectrogram? So spectrogram help us to analyze the planet, its temperature, its mass, details about it actually. So using the secondary mirror and the primary mirror, as you can see, this is the main mirror. So from the main mirror, the light will be passing. You can see this pillar kind of thing. Hello, can anyone hear me?
Yes.
Jagu, can you see this pillar kind of thing, like this wings kind of thing here? Hello?
Yes, you can see that.
So that the spectrum will be stored. So the spectrograph, so the light will be sent and will drips the light. After that, here in this pillar, it will be converted into spectrum. So what is the spectrum? So spectrum is nothing but an electromagnetic radiation. So as everyone knows, the electromagnetic spectrum, there are radio waves, microwaves, and extraordinary spectrum. So it will convert into radio waves that could travel for a long distance. So it will give pressure and compress. After that, it will convert into radio waves. After that, using the radial velocity, it will detect and it will transfer the image. After that, infrometer. So infrometer is nothing but it helps us in a highly resolution problem. Like the image is little bit not clear. So it will consist of two mirrors. It will consist of two telescope, which are the radio antennas inside it. So it will give us a proper clarity. So it's located at between the support module and axial scientific instruments located. After that, from this hole, as everyone could see this hole, my cruiser is pointing a hole. Can everyone see it?
Yes.
So here is where the radio, the space telescope will transmit its radio waves. So next, we will be seeing about few facts. So a space telescope is avoid filtering and distortion and synchronization of an electromagnetic radiation which they observe, and avoid light pollution which ground-based observatories encounter. They are divided into two types, which are satellite, which map the entire sky, and satellite which focus on selected astronomical objects or parts of the sky and beyond. So can everyone, this is an interactive question, like how it could point, how it could detect if you are aiming a particular planet like an exoplanet, how could you exactly point it? Can anyone tell me? Anyone? I will most likely keep it interactive, but I do not know. I don't like to interrupt when I was speaking. But anyway, I'll ask some questions. You can answer it. Harjit, any ideas, clues, anything? Anything? Am I audible? Hello.
Yes, you are audible now.
Jago, no one is not answering.
Because they are busy listening to your research.
Okay, guys, this is just an interacting question. Can anyone answer, please?
Repeat your question again, please.
So the question is like, how can you focus on a selected object? Like if you aim a planet known as exoplanet, how you could actually detect it? Using which method?
I can understand your question.
Okay. What I meant to say was like, can I explain you in Tamil?
Yes.
So
Nothing,
Jagu,
Vignesh. I want to say one thing, Vignesh. I was saying like I can understand something.
What I told, like I'll tell it in English again. So if you, for an example, if you aim a particular planet like an exoplanet, how you could find its exact position? How you can detect it? That's my question.
Transmitter?
No, it's wrong. I'm asking the method, not the part. Method which they use. In fact, they use it to find exoplanet. They use it to mark it.
By near something star or something like that.
No, I'll tell the answer. Before that, do you have any idea? Okay, so I will tell. So the method is radial velocity. And
I think
all.
you guys know it already, radial velocity.
Yeah, I
Actually,
asked
the other method
everyone
also.
to alert them, but no one is not answering. I think so. They are a little bit, like not concentrate. Guys, please concentrate. We have many questions. I'll ask many questions from now on. And also space telescope help us to distance from Earth imaging satellites, which are pointed towards Earth for satellite imaging applied for weather analysis and other types of information gathering. Chapter number 2. So let's go deep into this working. As I told, I explained the structures like so. Now let's go deeply. Working of space telescope. So how are space telescope working? And what are radio waves and what is radial velocity? So this is the agenda. So space telescope, it will transmit the radio waves. As I told, the spectrograph will convert them into radio waves and it will send. So this how only it works. So it uses secondary mirror, primary mirror, and axial scientific instruments, and also it transmits radio waves back to Earth. It will use the radio waves to transmit it back to satellite. So what are radio waves? So radio waves is an electromagnetic wave that is in the frequency between about 10 to the power of 4 and 10 to the power of 11 or 12 hertz. Until then, it will be as used for long distance communication. So these are the types of the electromagnetic spectrum. So everyone have a doubt. Why didn't they use gamma rays, X-rays, or many other types of electromagnetic spectrum? So the answer is, do anyone know wavelength? So wavelength is nothing but it will tell the distance between two frequencies. So a frequency is an object that means at a particular interval. Like when it comes up and down, the frequency is 2 hertz. Hertz is the unit that helps us to measure the frequency. So so the radio waves will help us to go to a long distance due to its wavelength. When the wavelength is higher and the frequency is lower, the signal could travel for a long distance. And also, now let's see what is a radial velocity. So it's a method that is used to pinpoint the planet's exact position. So when you pinpoint only, this is an important method, because when you pinpoint the location only, you can transmit the radio waves to its exact position. So the radio velocity is in our observatories. Like there are many observatories like NASA Great Observatory. So from the observatory only, radial velocity they will detect. So they will send the radio waves like from Earth, not from the space telescope. They will first detect its position. So they will detect and they will send the message to the space telescope, because they are only controlling. So they will send it to an exact position. So radial velocity. So when blue waves, like this sort of blue waves come, the planet is coming towards us. And when the red wave shows, the planet is going away from us. So in the proper definition, I just explained the concept. In proper definition, radial velocity, the radial velocity is the component of the object velocity that points in the direction of the radius connecting the point and the object. So chapter number 3, space telescope launched by countries. Agenda for the day: the first space telescope launched in the world. Hubble Space Telescope, James Webb Telescope, James Webb versus Hubble Telescope. So the first telescope launched in the world is Orbiting Astronomical Observatory 0802 is launched in 1968, and Soviet Union Orion 1 in the ultraviolet telescope aboard space station on Salyut 1 in 1971. So these three are the first telescope, but actually first telescope is 082 -2, which is orbiting astronomical observatory 0802. So now let's see Hubble telescope. So Hubble telescope is space telescope, but was launched in low Earth orbit on 1990 and remains in operation. It was not the first space telescope, and it was the one of the largest space telescope, renewed both as a vital research tool and a public research boon for astronomy. But guys, this was posted in this wiki. I have taken this content from Wikipedia. I understood and take, but it is so much long years ago. But currently now Hubble is not the biggest telescope. So can anyone tell what is the largest and most versatile renewed space telescope?
ISS.
Can anyone tell?
ISS.
Not ISS. ISS is satellite. I'm asking space telescope. Recently it was launched. Guys, am I audible?
Yes.
So, can you repeat your question, please? Sorry, I know James Webb Telescope. James Webb Telescope.
Yeah, that's the right answer. Now it's the James Webb Telescope, but long ago Hubble Telescope, but currently James Webb. So please ignore this content. Okay. And
I want to say another thing, Vignesh. Sorry for interrupting. Also, that James Webb Telescope is 10 times bigger than Hubble Telescope.
Yes, that's the extra point. I was coming to say it in a next slide, but I want you people to know We are already new and I want to just fill it. So it's a boon for astronomy. The Hubble Space Telescope is named after a great NASA observation known as Edwin Hubble. So he is only founded this telescope. He discovered this telescope first of all. He only made it, so it's named after him. Along with the component Gamma Ray Observatory and the Chandra X Observatory, and also Spencer Space Telescope. So these are the telescope was launched by Edwin Hubble and including Hubble Space Telescope. So some extraordinary information like the Space Telescope Institute select the Hubble's targets and processing result data. So the data will be transferred into a space flight center known as Gorton, GCIF, Gorton Space Flight Center. It controls the spacecraft. Hubble is 2.4 meters length and 7.10 meters tall. It's mirror as main mirror, and also many Hubble observations have linked to breakouts in astrophysics, such as determining the rate of expansion of the universe. And now let's see James Webb Telescope. So James Webb Telescope was designed primarily to see many planets. Infrared astronomy means that to discover and see many planets. This James Webb Telescope was formed. It was formed by USA National Aeronautics Observation, NASA, lead to development of telescope in collaboration. Only NASA didn't do. Some part was done by European Space Agency and Canadian Space Agency. The JWST was launched on 25th December 2021 during Christmas on an ESA Ariane 5 rocket. It was launched in rocket. ESA, it was designed by European Space Agency. Ariane 5 rocket, and it is indeed to succeed the Hubble telescope. It's more successful. NASA's flagship mission in astrophysics. The telescope is named after James E. Webb, who was the administration of NASA from 1961 to 1980. During the Mercury, Gemini, and much of Apollo programs were done by him. It will view objects too old and distant for Hubble. It's 100 times better than Hubble James Webb. And JWST primary mirror, the optical telescope element, consists of 18 hexagonal mirrors. So the inframeter has many mirrors, like 18 hexagonal mirrors, and the mirror is made up of gold platinum bare, which gives a better clarity, which combined to create a 6.5 meter and 21 feet diameter mirror compared to Hubble's 2.4, 7.9 feet tall Hubble. And also it gives the Webb telescope a light collecting data area of about 6.25 times as large as Hubble's Webb telescope collecting area, 25.37 square meters compared to Hubble 4.0. James Webb telescope versus Hubble telescope. So what is the difference? So as you can see, the mirror is bigger compared to Hubble. In James Webb, it's made up of gold and gold, platinum. When quiz, I will ask the question. While the Webb telescope can extract data for roughly more than 340 miles than Hubble, Webb telescope needs to be cooler than Hubble in order to capture data and find infrared wavelength of the light. So here, radio waves will be passed in this instrument. The infrared light will be put on, which could give us a better clarity. In simple words, if I need to say.
It is clearly we can see the exoplanets.
Yes, exoplanet or any other planet, not just the
not only planets, exoplanets or any other planets.
Yes.
You can see the other galaxies, all objects in the
many
universe.
I mentioned it as well. So with that, it could see, but I was also coming to mention, but you frequently interrupted.
No, I'm saying for audience they can understand clearly, much more clear.
I'm explaining what is infrared wavelength, but so it will give us a proper clarity to see many images. but therefore needs to be shielded from the sun's, earth, and moon's infrared radiation. And also now I would like to end this presentation. So you can contact me at Vignesh Anirudh H at CEO of Target Place at Vignesh Anirudh Lab at gmail.com. This is my email ID. So now quiz. So before we start the quiz, I want feedback from all of you people.
It is a good, great presentation.
It's a
And
good
I'm giving one feedback that you said Hubble and James Webb telescopes. So you can share the diagram of it. What are the parts and now they are
See,
formed.
Ajit, I was ready to do, but it took it will take many time to do. Okay, and everyone is presenting, not just me. I could cover all of them. That's not the issue. I was also thinking, but I just thought that we need to do at a particular timing sense. If we overcross it, no one couldn't even present. So that's only I didn't do. But I will do also a small presentation about these two separate presentation. Further, they need to
I'm
do.
also planning to do in James Webb. Already I planned to do in James Webb telescope.
Okay, continue.
Okay, Jagu, any feedback?
It's nice. It's a very detailed and so much research been put in. Well done. Super.
Thank you, Jagu. Improvements?
It's good and it's good.
Okay.
Keep doing it.
So now I'm going to screen share the quiz.
We need to put this link, quiz link.
1 minute. Jagu, I'm just putting the quiz link. Well, bear with me for a moment, Jagu. Oh, I'm just opening Chrome by now. I already copied the link, so I'll just paste it.
Next we have J Riya, Sruthi Rukmni.
Okay, Jagu, I just copied the link.
J Riya is going to do something very creative. Poems.
Vignesh, you share the link or you going?
I'm just going to share it.
Shruti, is it getting late for you?
Jagu, can you hear me properly?
Yes.
Okay, Jagu, 1 minute. I just copied the link, but I couldn't reach. I think so. TV has been on, so internet is a little bit lagging. I will just ask them to off the TV. Okay, they've off the TV. I've sent a link as well, Jagu. In my house. Have you got a Jagu?
Sir, who's next, sir?
Next is Riya.
Okay, guys, join quickly.
Okay, I'll join.
Okay. It means already start now because it's
Jagu, 0 people.
Can you wait, please?
No, because I only wait for 2 minutes. After that, Yarla joined.
Hey, this report gives some time to load for me. Da.
Okay.
Anyone else join? Because
It takes some time, Nipot. We should wait. I'm thinking so many people are choosing their characters and so many people are it is loading for so many people.
Yes.
Jago, I will do tomorrow.
Yeah, because we have 2 more presenters already here.
Or if I can do today, but I don't know time.
Next week you can do it. Vignesh, you can start. We have 2 more presenters waiting. It's already getting late.
1 minute. Suddenly, what happened is that on the TV it's lagging. Okay, just for 1 minute only. I'll just ask them to off the TV and I will just start the quiz.
Or we can cancel this quiz better. I think. Jagu, Vignesh. Vignesh, start. Start.
We started. Okay. Vignesh, you can read out the questions. HCL scientific instrument help us to analyze objects from the universe, analyze Earth.
Yeah, Jagu. Jagu, I did it in a different method. I did it in bar graph. I just taught a different method. If it's not okay, no, Jagu, I will in the next presentation I will do a different method.
Wants to buy us OAO2, Soviet Orion 1.
Yeah, OA2 is correct. I tried is that near itself the question will come, Jagu. For this question, Edwin Hubble is the correct answer.
Hubble. James Webb Telescope mirror is made up of gold or silver.
Darsh have got all of the questions full correct. Congratulations, Darsh.
Thank you.
Nice, well done, Dash, Harijit, Shruti. Well done, thank you, Vignesh. That's a wonderful presentation. Thank you so much.
Now we will get
detailed work being done. Well done.
So Darsh is the winner. Any feedback, suggestions again?
Yeah, you can put it in our group. Thank you so much.
Yeah, I'm thinking I get only one mistake da.
Yeah.
Because of I by mistake placed that all of the above placed that. So that what? I by mistake I pressed the wrong option. I know that it's wrong, but I by mistake I pressed that.
Okay, thank you, Vignesh.
Okay.
That's a wonderful presentation. Let's give a huge round of applause for Vignesh.
Thank you.
So that's the 50th chapter. Vignesh Anirudh presenting in the 50th chapter of Vaayusastra Pictures underneath. In the 50th chapter, we have a new creative presentation. That's by J Riya. She's a grade 9 student from Isha Vidya School. The topic is it's on Vaayusastra education methods. Rhymes of science.
Rhymes of science.
Science கவிதைகள்.
Right?
Science பாடல்கள்.
Sir.
நாட்டுப்புற பாட்டு கேட்டிருப்பீங்க.
Part.
தாலாட்டு பாட்டு கேட்டிருப்பீங்க. காதல் கவிதைகள் கேட்டிருப்பீங்க. இந்த சோக பாடல்கள் கூட கேட்டிருப்பீங்க. சயின்ஸ் கவிதைகள் கேட்டிருக்கீங்களா? இப்ப
சயின்ஸ் நிறைய பாட்டு இருக்கு சார்.
எஸ் ரியா, நீங்கள் இப்ப கவிதைகளை பாடலாம்.
நினைக்கிறேன் ஒரு பாட்டு எழுதிருக்கான்.
Share your poems.
Yeah, Jaggu.
And soon we are going
You
to
wrote something like those or idli. You wrote, right?
That's okay.
Jaggu, can you see the screen?
Yes.
I can see a bird and a color, multiple color river.
Okay, now rhymes of science. So presentation by me, S J Riya, Isha Vidya School, Nagar, and I'm grade 9. So introduction. Here are my haiku. Haiku are a kind of poems which will improve your IQ. Keep your eyes in queue to see something new.
Oh.
Okay, let's start up with our earth poem.
Okay. Earth poem.
So Earth is the planet where life is possible. Without Earth, life is impossible.
Nice.
Earth is full of plants. Which gives the oxygen we want.
It's not full of plants. Seriously?
Earth is balance.
Balance. Earth is like
It
mother.
would be better if there is no imbalance.
Oh.
Hey, what is balance, pa? Earth balance, I can understand that line.
Hey, later she'll explain. First listen to the poem. Because every line has some in-depth.
Earth is like our mother. So we no need to bother.
Oh.
Our earth can heal itself. Don't damage earth for yourself. So next is Building Rockets by Elon Musk and written by me.
Oh, you both written.
Yeah, she's the one written the poem. Stop.
So this poem is based on the story of Elon Musk.
Okay.
I wanna buy a rocket. But not have that much in pocket. This means the time he don't have that much money to buy a rocket.
Continue, understood.
Wait, I can build it. Elon built
Okay, Jag. Elon built rocket with his wit. Wit means willingness. His rockets fail. But he did not wait. Instead, he said, I'll
Never give up.
give up.
I-
He get up, rebuild it up. The rocket launched successfully. Everyone enjoyed the moment joyfully. Falcon 1 is the rocket name.
Falcon 9 is a successful one. Falcon 1 is a
Falcon-
failure one.
Is his aim. So next is about idli. Right.
Hey, I hear this poem already.
Great.
Yeah. Jaggu gave this idea on one set 3, I think so. Idli, you are round and soft. When we eat, we are loved. Can you tell the science behind you? Won't you? You are made with soaked black gram and rice, making us to think wise. Mix the batter. It has lactobacillus, which makes the batter soft and delicious. Then pour. The batter is sour. How do you cook? Let's take a look. The bacteria or yeast that are important for fermentation are killed. The air is get filled. We get soft and delicious idli, which looks very cuddly. Idli is used as astronaut food as it is healthy and good. So the fact about idli is the first Indian manned mission on space. The menu of is our very breakfast favorite. It is idli.
Yeah.
According to Defense Food Research Laboratory, DAFRL, small idlis the size of rupees coin with the sides of sambar powder and coconut chutney will be sent to space with the astronauts. The idlis will be using infrared radiation at a temperature of 700 degrees Celsius and the made moistureless further by microwaving. I'll send the link, you can also read it. So next is conclusion. The conclusion also with the poem, it's education. Education is very important. We can't buy it in any department. You can take high score. If you study without board, don't study it as career. It doesn't have any barrier. Don't choose a profession for money. Then the problems also many. So thank you. That's a quiz.
Wow, beautiful. I think all the
Hey, I'm having the about something Earth, right? I'm having the doubt in that.
Yeah. Okay. 1 minute.
all 4 poems are very beautiful. Nice.
How it can balance?
We can
Your
publish. Yeah, we can publish.
What
this.
you're coming to say in that line?
Already I have presented about equilibrium, right? It's all about that.
Oh.
Hello, but yeah, these are not actual poems. Better you could name it a different name instead of poem,
Yeah,
like
these
a
are
quote.
actual poems
Quote.
only.
Quote.
Hey, these
quote.
are poems, da.
These are
Poem,
poems.
poem need to have rhyming. But
This
there
is
is no
rhyming.
rhymings.
Hey, see, pa. Yes.
It's rhyming.
Bharat, a carrier, Bharat, money, many.
There are
Raghu, I have some own quote.
okay. There is a separate pattern. Riya followed. It looks it's nice. We already
Yes, we follow the patterns of
and
MC
it's
carrier,
soon getting
barrier,
published.
money,
All
many.
these are
It's rhyming only.
okay. Soon these are getting published. Okay. Well done, Riya. Nice, beautifully written. Thank you so much. Let's go.
Jagu, did any of
Let's go for quiz. We have Sruthi Rukmni.
Jagu, in my school, they said to write a poem in any topic. They said, I and my friend in school, we made about rockets and robots a poem.
Join the link. This
I
time.
want to just ask this thing like, is there any opportunity where we can publish our quotes?
I don't know. Quotes, I don't know. Poems, we can do it. You
Like
can
quotes
use
are,
your own blog.
Jagu, I think so. I like writing poems and quotes mostly. Like
Okay.
quotes I have written already once.
A
Like,
course we can say anywhere, somewhere you're going to speech in a stage means somewhere one person,
A lot of
everyone will
platforms you
stand
can-
up in chairs
You can
and
write
say
your own
people
blog.
that like this blog.
You can write your own blog, even Twitter, Facebook, Instagram. All these can be your publishing.
We can publish in olden days, so they will
There are people who got very
have
popular.
stage and they will
with
publish
poems.
that for some topic they will say and that become a code.
Say, go for it. Quiz lessons.
yes.
Shruti, are you there? Next, you are going to present. Okay.
Jagu, only one person joined.
It's okay. You can start.
Yeah, I joined Pa.
I also joined Rexy. I think you can reload your screen. Yeah, reload.
Yeah, okay. But if I reload, it when means
Vanda,
I
just
don't
start it off. Start it off.
okay.
Hey, why my name is not coming in your screen?
It's okay. It will come. Don't worry. First Indian food used as a I want to buy a rocket but not have that much in pocket. What is the meaning of this lines? You don't have enough money to buy a rocket. Okay. You don't have money. Okay. The answers are very straightforward. Any questions? What Elon Musk told when he started to fail? Do not give up.
Jagu, after the quiz, I want to show a few more slides.
We are doing it again also in the next week because the poems are very nice.
What, Jagu?
The poems are too good. So you can do one more time. The same, repeat the same presentation again.
Okay, Jagu. I thought more person would come, but
No,
only in a
it's very,
5
nice, it's very good.
guys, sorry, I forgot to tell this. But
It's okay, your voice is breaking.
early we didn't know well it did. Jagu, now can you hear me?
Yeah. Okay. So very close. Let's see in between. 30-point difference. What bacteria makes the idli batter
Jagu,
rise?
all
Coffee and milk.
details I forgot to.
This was there in the poem.
Why Harjit is not showing for her?
It's okay. Lactobacillus bacteria used to use lactose.
Jagu, it is asking me to due to some issues.
Okay. Anyway, Ria, you can present it again, no problem. So let's go with it. Thank you, Ria. That's a very good presentation. I liked it. So we are going to do the same presentation again one more time. All the poems are very nice, and we are going to publish it as well. Thank you, Ria. Well done. So, super.
Jagu, one more slide.
Okay. Can show it. Sure.
I'm thinking everyone. This is the last presentation, right, Jagu?
Choose your. Okay.
What is that?
Very
Present.
good. Can you show something?
Jagu, I thought to introduce my channel.
Nice.
So first of all, I thank to Jagu, Vaayusastra, my parents and my school encouraged me to create a YouTube channel.
What is the channel name?
Here is the channel name,
Scientific Riya.
Yeah. It's a nice one. Nice one.
Hey, you already created or you going to create it? Going to create it.
I have created on January 6th.
Yes.
You know, only I'm going to know it.
Super, super.
So that's all.
Yeah, I subscribe now itself.
Okay, share your.
Riya, can you share your channel link?
Just simple, put Scientific Riya in YouTube search, it will come down.
Well done, well done. Thank you so much, Ria. Superbly done. Okay. Next, let's have our last presenter for the day. Chapter number 50, Sruthi Rukmni Shankara Narayanan. So, Sruthi Rukmni is a grade 9 student from Sri Chaitanya Techno School, and she is going to present on the topic Artemis, the wet dress rehearsal. Okay, yes, Shruti Rukmani, the stage is all yours.
So today I would like to present about the Artemis 1 wet dress rehearsal. It's actually an event that is happening in NASA. It started on April 1 and the last day is April 3. So first you need to know what is the wet dress rehearsal. So the Space Launch System, the SLS rocket, an Orion spacecraft, and exploration ground systems are the foundation of the Artemis mission.
It is going to launch today. Today only night midnight. It will be something like tomorrow in Indian time. We can according to India we can say tomorrow it is a launch.
Yeah, so but it is not a real launch, not today. The real launch is not now. So they have to test it. They have to make sure everything can go according to the procedure on the real launch. So they're testing it right now. They're testing all the exploration ground systems, all the most important parts of the mission. SLS is the only rocket that can send Orion astronauts and large cargo to the moon on a single mission. So they have to make sure everything can be followed according to the procedure. The Madras Rehearsal will take approximately 2 days. So this first step of the Madras Rehearsal is the teams will begin by activating the apparatus needed for the launch, and they will start the countdown. So they will have to power on the launch controllers of the different rocket and spacecraft along with the ground support equipment. Next, the teams will load more than 700,000 gallons of cryogenic propellants, including liquid hydrogen and liquid oxygen, into the rocket at the launch pad on the mobile launcher, while according to the timeline they will use on the actual day of launch. So they have to rehearse every stage of the countdown. This means they will also rehearse the weather briefings, the pre-planned pauses in the countdown. They will condition and replenish the propellants when they need to, and they will do validation checks. Once the launch controllers reach the point just before the rocket's RS-25 engines will ignite on launch day, they will go back to the T-10 minute point and resume the countdown after a pause. They will then intentionally halt the countdown at about 10 seconds before the simulated lift-off to illustrate the stopping of a launch and draining the propellants from the rocket. So they need to make sure that the teams know the emergency procedure for stopping the launch. Because if a technical or weather issue arises prior to the countdown, they need to know how to stop the launch quickly before takeoff. This is a picture of the SLS space shuttle. It's the newest version, and it's what they're testing right now. This is the Orion spacecraft.
So when is the real launch?
Sruthi Rukmni, you got disconnected.
So I don't think there is a proper date for the real launch yet.
Okay.
They need after
But
this.
they said today what they are doing, but
They are making sure everything is proper. So when they're launching, they need to make sure that there are no problems with the system.
I hear some news that they finish all things.
Yeah, I think just about this morning, for us this morning, they finished.
They according to days that is they are sleeping. They make sleeping in America. So
It's 11:50 a.m. in America.
Okay, no problem. Well done. Done. So Riya, Shruti Rukmini.
They want to make sure that the Artemis 1 launch can take off. So if there is a problem and the rocket burns up halfway in the middle of the Earth's atmosphere, they have to make sure that the ocean is underneath so that it doesn't fall on us. So they need to calculate everything. So that's why they're doing a rehearsal. So they're just a practice test run.
Okay. So, Shruti, you have any quiz for the audience?
Nah, Jaga.
Okay, thank you so much, Shruti. That's a quick, simple, fast present.
Yes, Jago. We can
Well
make.
done.
I wanted to do during this time itself.
Yeah, no problem.
That dress.
Nice, nice. That's a quick, nice one. Yes, Riya, it's been too late. Now next week on the Riya, so no problem. So I will share your channel in our researchers group, and also
I subscribe your channel, Riya.
even I have done subscribe. I have subscribed your channel.
I also subscribed your channel.
Thank you so much. So
You too subscribe my channel.
yeah, I have done it.
I have
already.
also done.
Thank you guys.
Okay, thank you so much. So see you all next week. Bye bye. So this is chapter number 50 for you. We have some amazing poems, amazing topics. Thank you so much. Bye bye.
Okay, sir. I am